Welcome to Walkabout the Galaxy, the whimsical astronomy podcast where the science is universal, the opinions are personal, and the hosts want their sandwiches.
And coffee.
And coffee. You did get your sandwich eventually.
I did.
But your coffee, you're going to have to wait.
But it was a highly distressed.
It was distressing.
We are Strange, Charm, and Up, the Astroquarks, also known as Josh Caldwell.
Addie Dove.
And Hannah Sargent.
Coming to you from the Walkabout studio at the University of Central Florida. Remember to subscribe to us on all platforms, including YouTube, Facebook, Twitter, and Instagram. See our hashtag shorts and our Walkabout shirts on YouTube. If you'd like to get one of those shirts and support STEM education at the same time, send us an email at wtg@ucf.edu. Our Stumper today is a little bit of a throwback, you reminded me, Addie.
I did.
Because I had not checked the master Walkabout database
Yes,
for past
it
Stumpers.
definitely exists.
And it harkens back at...
Sorry.
Sorry?
The Almanac.
The Almanac of Stumpers. Oh, that's a fun book.
The Almanac of
Can we
Stumpers.
publish the Almanac of Stumpers?
Well, that'll be part of the Walkabout the Galaxy Guide to the Universe.
Perfect, yes.
Coming soon.
It is. Just like our
To
second
TikTok
music video.
platforms.
Just like our music video.
Yes.
But Hannah didn't do our original version
Probably
of this,
not.
which was slightly different, which is based on my own insecurities and phobias.
Excellent.
Which is scarier, outer space or the ocean?
I actually had this conversation very recently with a friend.
Oh.
Yeah.
Where'd you fall down? Where'd you come down?
I would rather be in space because I don't even like swimming in the sea. If seaweed touches my feet, then I'm like suddenly terrified.
So the things in it.
I hate the things in it. I hate
you're hiding.
I hate the abyss
Yes.
nature of it and the pressure.
Not the movie, though.
Well, that's also. I mean, it's a good film. I
Yes.
enjoy the film,
Yeah.
but it's terrifying.
It is. It's an excellent movie, and it is terrifying.
Yeah. So just knowing that all of that is like trying to crush you.
Yes.
And I know that space is also hostile, but it feels less crushing.
Oppressive.
Yes.
Yeah, we don't know what's out there to get us yet,
Right.
Yeah.
other than the vacuum and the cold or the
Yeah.
heat or whatever.
What about you, Addie?
How is this question phrased?
Which is scarier?
Okay.
Space or ocean?
I
I had to check my notes.
Yeah. I think scarier is also ocean.
Okay, me too.
Yeah.
I'm totally there's something about being, if you're out in the ocean, even on a perfectly safe boat or whatever.
See, that doesn't.
And knowing that that scares me.
Oh.
If I just stop to think that there's hundreds or thousands of feet of water beneath me, that's this, and I know that that's compared to space, nothing.
Do you feel? What about when you're in a plane?
I'm okay with that.
Okay.
I feel like we are biased though because that's a question about the things that we're interested in, and therefore we have more awareness, and like we're just generally more comfortable thinking about space.
Also, it's kind of easy for us to say, "Oh, I'd rather be in space," when we haven't been in
yeah,
space.
we've never been.
And maybe if we'd been in space, we'd go, "Holy
Oh my gosh.
Yeah, yeah. I'm still in no rush to go to space, so
okay.
I'm just pretty content in land based
Okay.
activities.
All right, fair enough. Well, today we'll talk about people going to space and where on the moon they will go.
Breaking news.
This is literally breaking news just within hours of this recording.
If we were, we could do a breaking news chyron on our YouTube video.
I don't know that word.
Chyron? It's the little thing that goes across the bottom of the
Yeah, I
screen
didn't know
on
that word.
newscasts.
I thought it was
Isn't it?
Like a
Is it-
banner or
I thought that was called a crawl, and I thought Chiron was a trans-Neptunian object or a moon of something. Isn't there a centaur named Chiron?
I don't know
Or a moon?
what.
If there's an outer solar system body, I can't remember if it's a moon or a.
It's not Sharon, is it?
No.
Okay.
Anyway,
Maybe I'm saying the wrong word.
we diverge. We'll also talk about detective work to figure out the bombardment history of the moon, and some interesting astrohistorical detective work to figure out the stellar evolution of Betelgeuse, one of our favorite topics, which
A
sheds
continuous
some light
question.
on whether and when, not whether, but when it will blow up. Answer, don't hold your breath.
Okay.
Yeah.
It is indeed called a chyron, CHYRON.
Interesting.
And it was added to Merriam-Webster in 2017.
You are definitely more up with the times, the lexical times, than I am.
The lexical times. If that's not a magazine, it should be.
It is, I think, but in Hogwarts. The lexical times.
Yeah.
But first, this episode of Walkabout the Galaxy is brought to you by Veridical paradox. If you're tired of Zeno's paradox and have, in fact, successfully gone from point A to point B, try a veridical paradox. These head scratchers may hurt your brain, but they'll also teach you how the world really works, because while they may be absurd, they are demonstrably true. Hilbert's Hotel, with an infinite number of rooms, all of which are occupied, can indeed accommodate a countable infinity of additional guests. Stretch your brain and broaden your horizons with any of the many veridical paradoxes, including the Monty Hall paradox, Arrow's impossibility theorem, and the ugly duckling theorem.
Aww.
Veridical paradox. It's not TV, it's HBO.
Netflix.
You have had too much coffee today. That was the closest I could come to finding a tagline that maybe was itself a veridical paradox. A veridical paradox is a paradox that seems absurd but is actually true, which is different than a falsitic or something like that paradox, which is like Zeno's paradox, which isn't true. Zeno's paradox says you can't cross the room because first you have to get halfway there, and you can't get halfway there because first you have to get halfway to halfway there, so you never get anywhere. But that's BS.
Yeah.
So that's a different kind of paradox than the veridical paradox, which is basically says quantum mechanics is crazy, but it's also true.
Wow.
You're disappointed.
HBO.
I was trying to remember.
You're right.
I was trying to
Yeah.
remember what the HBO tagline was to then link it back to the paradox. No, So what was the tagline?
It's not TV.
It's not TV, it's HBO.
Right. Okay.
So it
But
kind
that
of is
works
TV.
now.
It kind of is TV.
That works now
but it also
because
is
there's, like,
not
streaming.
TV, it is HBO. Anyway, it was difficult to come up with a tagline for veridical paradox.
I think you could have swapped out HBO and
done something.
yeah.
I thought about doing. And
I mean, the sponsor could have.
the sponsor could have done that. So on space news, we have.
There was just a Starlink launch, I think.
Yeah.
today.
Barely newsworthy these days.
I know. I didn't even go out to look at it.
I'm over it.
We have talked previously about Discovery missions, which are
Yes.
planetary science exploration missions,
Yes.
and the Astrophysics corner of NASA has their own class of missions. And
They do.
Discovery missions usually, not always, but are usually like go somewhere, like go to a comet, go to an asteroid, go to Venus or something like that. The astrophysics missions are typically observatories of some sort, specialized space observatories. They've come down with a sort of finalist list.
Yeah, so these are the explorers, you said, right? The
Yes.
explorers program. And so these are like small to medium-sized missions.
Which means sort of $100 million-ish ballpark.
They are funded. So there are two teams that were selected to do 2 medium explorer missions and 2 explorer missions of opportunity that will go into a mission concept study phase. So the 2 explorer teams will get $3 million each for a 9-month mission concept study, and that's the Ultraviolet Explorer, or UVEX, and the Survey and Time Domain Astrophysical Research Explorer, or STAR-X.
I was going to say that must assemble into an acronym.
Yes. And so the first one, the Ultraviolet Explorer, obviously is going to survey the whole sky in UV to look into galaxy evolution and the life cycle of stars. And so it will have to be a spacecraft because it's in UV, right? And I mean, these are all
Pesky
spacecraft,
atmosphere,
but that's
yeah.
why they need to do this in a spacecraft. And it's also going to try. It sounds like it's going to try to be responsive to like other detections and stuff, because it's going to capture light from the explosion that follows the burst of gravitational waves and things like that. So they're going to try to have it be responsive, I think, maybe to other detections or something. I'm not sure.
Like
and
a
then,
rapid.
Yeah, I don't know.
a rapid response to a gravitational wave detection. You
Yeah.
swing around and see if you can pick up something bright in that corner
Yeah.
of the universe.
Yeah, I guess so.
Hmm.
And then the Star X would use X-ray and UV telescopes to study supernova explosions and active galaxies. So it's gonna do deep surveys, and that'll be interesting. So then the two missions of opportunity will each receive $750,000 to conduct a 9-month concept study. So these are like a little bit behind, but do some studies. The Moonburst Energetics All-Sky Monitor, or Moonbeam, which would operate in a halo orbit. So that's similar to like what Gateway is going to do, which is sort of a big orbit that sort of is
Very
in between the
elliptical.
Earth and the Moon. And you can see the whole sky most of the time. Like you don't have Earth blocking your
Right. So
sights.
it's not looking at the moon at all. It's using the moon as a sort of anchor point for its orbit.
Yeah.
Mhm.
And so I'm not really sure. Yeah, so it's a little bit of a
bit
strange
misleading.
name. Yeah.
Yeah.
We all got excited.
Well, it's moon.
Yeah, I'm excited to see what happens as we kind of do progress further on and more permanent, like, things going on around the moon. These different divisions collaborating more. So when the Astro
Right.
division need to be collaborating with lunar exploration peeps to
For example, when they want to put a telescope on the moon.
exactly.
Yeah.
Yeah. It's gonna be interesting.
Yeah, so it's gonna watch for bursts of high energy gamma rays, and then rapidly alert other telescopes so they can study the source. And then finally, the Large Area Burst Polarimeter is LEAP. The B is silent. There's no B in the acronym.
And where are they getting? What's it's called? LEAP.
Large area, where the L and the E come from large.
That's
Of course.
I call.
Because the E is really prominent.
I
It is
call-
if you capitalize it.
I call foul.
Yeah, I hate those. Study
It's
gamma
really
ray
lab-
bursts. Yeah, lab.
Lab.
Study gamma ray bursts from
God.
energetic jets from black hole formation and other like neutron star mergers and stuff like that. So they're going to look for energetic jets, and this one is going to be an ISS mounted telescope,
Oh yeah.
which is interesting, but also
A little bit concerning, considering that ISS's days are numbered.
yeah. But maybe it would
The
be
clock
like
is
an
ticking.
orbital reef mounted telescope.
Oh, yeah.
That's just my editorial,
a
not
future, right? A future imagined private
Space
space
station.
station
Yes.
that would lease space, for example,
NASA
physical space,
or
real
to-
estate to
Yeah.
NASA or
Industry.
something. Yeah. So it'll be interesting to see if those happen. And then we have exciting moon-related space news. What you've dubbed, Hannah, as
Artemis Corner.
Artemis
Because there's going to
Corner.
be a lot of Artemis news coming up over the next few years. So
Okay. Are you going to do an Artemis Corner? Is that going to be a regular?
I
recurring
think
feature?
you know, maybe once every
Couple
Every
weeks.
few
few
episodes.
weeks. Yeah, we'll have a little Artemis Corner.
In 2 weeks.
In 2 weeks, we're going to have Artemis Sesh. Like, there's going to be a
Yeah.
lot of Artemis.
There is. Well, actually, in 2 weeks,
We will-
approximately, we will
we
be
will be-
recording.
We will be doing an Artemis Sesh
We
because
will.
we will be doing a special episode at DragonCon.
Live at DragonCon in Atlanta.
So get
Recorded
ready.
live.
Recorded live.
Yeah.
That's true. It'll be live for the people who are there.
We should maybe
the
do
audience
a
with
we should
us.
do a Facebook live stream or
We did that
one
one
of those
time.
things.
Was
We
it
should do-
successful?
It worked.
I mean,
technically.
yeah, functionally.
You'd have to ask the 9 people who
But-
watched
right.
it whether it was successful.
We did it at Nerd Night, I think, right?
That's right.
That was the
yeah.
time we did
No,
it.
we should totally do that.
That'd be fun.
Yeah.
So, in Artemis news this week, 2 things of interest. So, firstly, Artemis 1, which will be launching very soon, which, as we just said, and
It rolled out.
oh,
It's
so
at the
yeah,
pad,
it's
yeah.
at the pad. So I'm going to go check it out.
Nice.
Going to Kennedy on the weekend to go see it again. And there's an article that's been written by Eric Hand here, and he's basically brought to the attention of more people a big issue with some of the payloads that are going on Artemis 1. So Artemis 1 is carrying 10 CubeSats. So these are these little 10 by 10 by 10 centimeter little modules that you can then build up into sort of longer, like 2 or 3 together or 6 together. And it's supposed to be kind of same size, easy to reproduce and cheaper to make parts. Supposed to be. Still kind of expensive to make.
Unless you do a crappy job.
Well, hopefully these 10 payloads aren't crappy.
No, I'm sure they aren't.
But there's going to be a whole bunch of cool, interesting studies that are going to happen. In terms of lunar science, there are a couple looking for lunar ice. One of them, it looks like it's a LunaH-Map, but before the recording, you said it was LunaMap.
It's just LunaMap. The H is silent.
Again, the H is silent. So
it's very confusing because here you've got large thing where the E is big to tell you to pronounce it. And LunaMap is big L, little U, and a big H.
Big H, but then you can't say it apparently.
It's because it's mapping hydrogen.
It's hydrogen.
Is why it's
so that's why it's there.
I
so I
think
understand
LunaH-Map makes sense, like because you want to emphasize the hydrogen. So anyway, so it's looking for hydrogen, and it's going to improve on some data that we already have, and it's kind of cool because it's this kind of technology has never been operated in such a small sort of payload before. So it's kind of making these kinds of measurements more affordable for more people to get involved in space.
Yeah,
missions.
So it's a neutron detector is the type of detector it is. And I'm extra excited about this because that is the predecessor to an instrument that's going to go on lunar Vice, which is our mission to the moon.
Surface of the moon. And it's the same group that's
so Craig Hargrove is the PI at Arizona State, and he's
for LunaH-Map.
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 And he is a co-I on our project. He's the instrument lead for that.
So these CubeSats are what are called secondary payloads, and this is part of the reason why there's this bit of controversy, which you haven't yet explained to us, because the primary mission of Artemis 1 is sort of flight validation of this giant rocket, the SLS.
Is it going to get there?
The
capsule.
flight systems, the Orion system, make sure it can go there, make sure it can fly and operate correctly and safely return to Earth so that the next time you can put people in it. And that's really NASA's number one priority.
So they have to do what they can to prioritize that objective.
They are prioritizing that, but once upon a time when they created this, they're like, we're going to the moon, we got buckets
of extra space.
Yes, we have. There's room. Anybody want to ride along, kind of thing. And so that's where these 10 CubeSats come along. It's like, sure, we'll throw you in there.
And so they're going to be doing some interesting science, and but the problem is that 5 of them haven't been able to recharge their batteries. But
this is so stressful.
Half of the payloads have not had the opportunity to recharge. So the NASA engineers were concerned that with the way that they are configured within the rocket, or the process of charging them might cause electrical discharges that could harm the rest of the rocket, and they have to prioritize the primary mission. So that means that currently the LunaH-Map's battery reserve is probably around 50%, and they need about, if it goes below 40%, the CubeSat will not be able to open its solar panels to actually recharge. So below 40% is kind of end of CubeSat.
Yeah, I was alarmed.
I was so stressed out when I read about this.
Learned about this.
Because it's really hard. So part of the reason is because they've sat on the rocket longer than they expected, and then some of them weren't allowed to recharge, right? And it's just like, batteries are so hard to figure out for CubeSats. Having done this, right?
Yes.
Batteries are so hard to figure out, and like maybe that's what went wrong with ours. We don't really know.
I believe that that's what went wrong with mine. Is that the battery was in too low a state when it launched, and then it was trying to do things without having sufficient time to recharge, which is, we could have designed things differently.
Yeah, and we didn't have to deploy solar panels on our CubeSats. They were just there. But it's still you have to be able to build up charge, and there's a lot of other things.
So having a small payload, it's great in terms of, lower mass, so therefore it's cheaper to launch and all these things, but then there's very little room for
error.
And battery power backups and
extra batteries.
Yeah, but they put these payloads in this stage adapter ring is where they are about a year ago.
Yeah.
And I imagine that when they did that, they were looking at probably 6 months
Like
to
a spring
launch,
launch
but it's
time.
turned out to 12 months
Yep.
at least, because it hasn't actually taken off yet.
I like this quote. They've got, I think this is from Hargrove, so you can't agree to take stowaways and then kill them. But then they say it wouldn't be a CubeSat mission if you weren't anxious. I'm like, it wouldn't be any mission if you weren't anxious.
Yes.
That's not unique to
I think,
CubeSats, but
yes, I think you get...
Different reason to be anxious.
different
Yeah,
reason,
it's not
additional
like
reason.
Yeah, nobody was anxious for the launch of JWST, right?
No.
There's no
perpetual
nerves for
anxiety.
that at all.
No
right?
nerves.
So that's Artemis 1, but then breaking news.
Da, da, da.
Yeah, I couldn't think of a
Da-da.
chime for breaking
Oh.
news. Artemis 3, which is the first crewed.
We'll have to Google and insert a chime.
Yeah,
an
insert a chime
appropriate
here.
You didn't like mine?
No.
It wasn't impactful enough.
Boom!
There we go. I think just
You
that.
need flashing lights and things like that. For,
So Artemis 3, first crewed mission from the Artemis program.
Woo!
First crewed mission since Apollo. So like
first one to
to
land people
people
on the moon. The Artemis 2 will have people,
oh sorry, yeah,
but it will
I
not.
stand
They
corrected.
will just fly around the moon.
So first mission to the lunar surface.
Yes.
For the Artemis program, it's launching. I think estimated 2025. We shall see
Yes.
how that timeline stands.
Accurate that is.
And today they have announced the 13 candidate landing sites at the lunar South Pole.
Yeah.
And these are, I was sort of amazed to see these, and I know part of it is sort of like how they're drawn and stuff, but also it reflects, I think, my own historical biases from the Apollo era, where it was like, can we get there? Can we land? And then they over
They got
the
a
course
little
of the
more
Apollo
exciting landings
mission,
over
they did
Well, the first landing ended up being more exciting than they
than they
expected
thought
it to be.
Yeah.
Right, yeah.
But
they're sort of like, let's pick a big, flat, smooth area, and these don't
Turns
look
out
like that.
those don't exist at the South Pole. It's
And-
part of the problem.
And also,
Yeah.
what they're looking for in a landing site has changed, and
Yeah.
landing capabilities have also changed.
Yes.
So in terms of what they're looking for, they wanted a place which has quite an extended illumination time frame. So
Yes.
for solar
for
power.
solar,
And thermal reasons.
And thermal.
It gets real cold when the sun
Right.
sets.
yeah, but then also close enough to a permanently shaded region, which is where we're expecting these water-rich.
I think
Regolith
we
or
talked
ice
recently
rich?
about lava tubes,
Yeah.
where the temperature is lovely.
Yeah.
Inside it's dark.
Uh-huh.
Outside it's bright.
But I don't think we'd expect the deposits in the same way on most of the lava tubes.
I think lava tubes will still come as part of future crewed
Eventually.
exploration. But for now, like there's a big interest in the South Pole in general on the moon,
Yeah.
just because of these large
Special
water
illumination
deposits.
characteristics
and
and
illumination.
then the ice.
Yes.
Right?
Yeah,
Stars.
but these areas to get the most illumination, really in the South Pole, you need to go to high regions. So back in Apollo days, looking at ideal landing sites, you wanted large flat areas, whereas now, a lot of the areas of interest are quite, sloped or near to slopes.
One of the interesting, like the South Pole is just it has a lot of topography. Like it's not flat. There's a lot of topography change. And
It's heavily cratered.
It's heavily cratered, and there's just like a lot of
It's very interesting,
Yeah.
but a bit of a nightmare for landing. But now landing ellipses are sort of smaller than they perhaps were in the past, because we can get more accurate landing or have more control over our landings. And I liked the way it was described earlier that so they've got to have a number of different landing sites, because depending on what launch window you go in will depend on which site has got the best illumination conditions. So it's not like they're going to pick one and then that's where they're going. It depends.
Do we know the duration of the visit to the lunar surface?
6.5 days
Yeah.
for this first mission.
And then within each of these 13 regions, they've described them as sort of 13 parking lots. And then within that, there might be a number of different landing ellipses they might choose, which
are
would be
pretty
your
small.
parking space.
Yeah.
And they're 100 meters or something
Yeah,
across.
a landing ellipse is about 100 meters across. I think these regions are like 20 kilometers or something. I forget.
15 kilometers, I think, across.
Yeah.
And then sort of football field sized, and that gets back to what you were saying about there's been some evolution since the Apollo era in terms of
Landing technology.
landing technology and ability to nail the landing.
Yeah.
Although they really did, Apollo 12, part of its mission was, how well can we nail our landing site? They wanted to land near a previous crewed robotic lander surveyor or something. Surveyor number.
Yep, number.
And they did. They landed
did.
150 meters away from it or something like that.
Which is pretty
in
good.
1969.
Probably too close. Yeah.
But in any event, yes, they're a little bit more adventurous here for all sorts of good reasons.
And they've announced these 13 as well, so that they can get insight from the community now, that people can go and focus on these regions, dig out as much data and information as they can, and make recommendations on these landing sites. So this will help them kind of narrow down where the crews are going to focus depending on their launch window.
Right. Let me drop our trivia on you before we do our next two topics.
Don't hurt us.
Well, it might. It has some heavy trivia. It
Oh,
has
no.
to do with Artemis in some sense. It's about rockets. Since
Heard of them.
Jim isn't here. You've heard of them?
Heard of rockets.
You've heard of
Yeah.
rockets.
Oh yeah, this is good because Jim isn't here. We can do a rockets question.
So So SLS is Space Launch System, and Artemis is the project.
It's like the program.
Right.
Yeah.
So that's sort of like SLS is to Saturn V as Artemis is to Apollo.
Sure.
Or SLS is to Artemis as Saturn V is to Apollo.
Yeah,
That would be a
there we
better way of wording that. So today's trivia compares SLS to Saturn V and other rockets.
Oh no.
And it's very simple. Okay. It's very simple and it's multiple choice.
Okay.
Which of these rockets has or had the greatest thrust at liftoff? Saturn V,
Mm-hmm.
the SLS, which is on the pad, the Falcon Heavy, which has flown, New Glenn, which is Blue Origin's new orbital launch vehicle that has not yet flown, or the N-1, which was the Soviet heavy lift rocket for their human lunar program in the 60s and 70s. So which of those five, and if I grant that two of those have not, only one has not yet flown. The New Glenn is the only one of those that hasn't flown. Which of those has the greatest thrust at liftoff? So
Usually
we'll
have
come
better
back
knowledge
to that.
about Russian rockets.
We'll come back to that, and of course there will be a follow-up trivia after that. But before we get to that, we did have another lunar science story.
We did. Oh yeah, we did.
Did we?
We do.
We do. We always have another lunar
Lunar
science
science
story. So there was an interesting article that was recently published in Nature Geoscience about the bombardment history of the moon. So how the moon gets pummeled, and some more interpretations of how that's happened over time.
I like the word interpretations. I'm just it always makes me think of like interpretive dance or something.
Yes. Let's do an interpretive dance of moon bombardment. So it's interesting. So a lot of times on the moon we look at craters because there's a lot of them, right?
And craters
And they're
can tell
pretty
us
good
a
to
lot.
look at.
They can tell us a lot
Yes,
of things.
no, it's actually because they can tell us a lot of information. So not only like how big they are, that tells you how big the impactor probably was, but like when we're looking at trying to understand the history of the moon, we look at craters because they tell us how old a surface is relatively. So if there's like a lot of craters in one area, it's probably an older surface because it's had more time to get hit with crap. I almost had to have a blooper there. It was going to rhyme better. And we know that there's like this old history of there were some really big impacts like long ago in the history of the moon when there was bigger stuff around to smack into the moon. And then you get smaller stuff over time pummeling the surface. And as this happens, it eventually your surface gets what's called saturated. And so like you can't have another impact without erasing a previous impact.
Craters on craters on craters.
Yes, all the way down. Craters all the way down, except not
Right.
actually.
The new crater creates the crater density is saturated, so that you have like the details are fluctuating, but the number of craters any given size, you can't make more smaller ones without erasing some smaller ones.
Exactly.
And so on.
Yeah. Yeah. So we know we can use that cratering rate, or we can use that to sort of figure out a little bit about the cratering rate and get relative ages for the surface, but it's still hard to do like absolute age dating with any of that. So for the moon, most of our absolute age dating actually comes from like returned samples from Apollo. But there's this cool study that actually wasn't just looking at the surface cratering, but actually used gravity data. So used data from the Grail mission, which is super cool. We haven't talked about Grail in a long time because there hasn't been a lot of new stuff, I don't think, from it in a long time. But Grail was an
10
acronym.
years old.
Yeah, Grail is an acronym for
Gravity something something lunar.
Yep.
Gravity's Recovery and Interior Laboratory.
You're right.
What was the?
It's
yes.
not lunar. Gravity Recovery and Interior Laboratory mission.
So Grail is a mission, and their Grace was the Earth observing mission that was the analog to it. So Grail was a mission that looked, as it orbited the moon, it made this gravity map of the moon, and so it did it by like understanding where it was in its orbit around the moon, and it produced this really, really high resolution gravity map. And we actually have a better gravity map for the moon than we do for Earth.
Whoa.
Which is kind of cool.
How did
That's
that?
amazing.
Yeah.
Why?
Because like there's just
There's
I think
fewer
it's
sources of noise.
I think
basically.
it's because there's less noise, right? Like the oceans and the land
And the
mass
atmosphere.
and the
Yes.
atmosphere cause a lot
Constant
of
change.
Those are affecting.
yeah. So you don't get as high resolution and higher order numbers. Of
the
the
Earth is
gravity.
more time variable, so
Yeah.
you're making these measurements by spacecraft's Doppler shift. So as it's flying along, you're seeing all these measurements, and with the moon, you can go around and around and around and around and around, and you just build up all those measurements, and you're measuring the same thing every time.
Yeah.
But with the Earth, at a certain point, storms and tides and climatic effects that move the hydrosphere and the atmosphere around,
Which is heavy.
they're heavy at the level that we're talking about here. So then you're measuring a different thing. So
Yeah.
interesting.
So they
I
have
hadn't thought about that.
yeah. So it's higher precision for sort of how the gravity is distributed within the Earth. And I think we talked about something recently. Maybe this was in a life conversation, not a podcast conversation, but about how like the Earth the moon has really weird distribution of mass actually, and it has some areas where there's mass concentrations and there's some weird gravity things happening. I think it was on the so it's a bit lumpy, and that actually makes it hard to just orbit around the moon
at a low altitude.
Altitude. Yeah, I think that was on the.
Oh, that was recently.
Yeah.
Yeah.
Well, sometimes it's hard to tell what's regular life and what's
So how does
podcast
Grail
life.
tell us about these craters?
So Grail is actually, so the paper is telling us about actually the porosity of the crust. And so this gets back to the cratering, which is like you expect that as the impacts happen, it's going to change the density or the porosity of the crust of the upper layers of the moon. And so they use the gravity data to map the porosity. So because it's so high resolution, they can sort of pull out how densely packed things are. And they find, and then they use this to look at like different areas of the lunar surface that are estimated different ages from different cratering features. And they find that, and I want to make sure I say this right because I've read it and like, but so the porosity of the crust sort of like tells us also about the history. And with their models, it showed that, which they sort of, so I actually disagree with their hypothesis of what they thought was going to happen.
Okay.
But so their hypothesis was that over the history of the moon, they thought the porosity would increase steadily over the history of the moon.
More fluffy.
So get more fluffy because as you get hit more, you get more fluffy.
You're breaking rocks up into powder.
And it's sort of flying up and landing and all of that stuff. But instead they find that the predominant porosity of the lunar crust was generated early on when you had these big basin forming events, so bigger impactors that formed what we call basins on the moon, which is just the bigger craters. I think they have to be at least like 300 kilometers or something like that.
Mm-hmm.
And so they instead find that they had it increased early on, and it's been decreasing slowly since then. And so this probably indicates that there was a lot of porosity early on, and then it has implications for like how impacts have changed the surface then over the course of time. But here's the thing, like, sure, you can think that impacts are going to sort of fluff things up more, and we call it gardening on the moon with all the micrometeorites hitting the surface. But like, we know that the porosity and the subsurface densities are really complex, and that you get like more packing in certain areas due to bombardment over time.
Yeah.
So like, to say that you're just always going to have a net decrease in porosity seems far too simplistic for me. And also, as you have impacts, it's like pushing stuff down.
Yeah.
In addition to fluffing stuff up.
I'm struggling to wrap my head around it a little bit, because we know that the older regions, so like the highlands, their regolith layer, which is this churned up like granular material, is like tens of meters deep. And then in the mare, which is like the younger regions, this regolith layer is only like a few meters deep.
Yeah.
So I assumed that below the mare you'd just have solid rock, so I presume that those younger regions would be overall more dense, because there's the top surface is, you've got a few meters of granular material, and then the rest is all rock, whereas in the older regions you've got more of this less compacted material
Stuff.
Yeah. So I'm trying to understand
so it
how
has to do with like not just thinking of just the upper levels, right? Because it includes the crust. So like, one of the things they say is that these really big impacts cause a lot of fracturing in some of the underlying crust, right? So not just like the stuff that gets ejected and stuff like that, but there's actually like fracturing underneath that could create additional porosity in the crust.
I see.
So like, those big events create sort of much more large scale porosity.
Yeah. I mean, they, looking through the paper, they made some simplifying assumptions about what happens to the porosity when there's a basin forming impact. And, those can't be tested experimentally.
Sure.
But I think, and then also there are some limitations that they recognize in their conclusions about relative age dating, and this region looks older or younger than this other region. But I think it's something that I had never heard of before, considered as a way to look at relative aging.
Yeah.
I've always thought of it as these cratered surfaces, and you sort of look at the freshness of the craters and the distribution of them, and whether you're, a young surface, very simplistically, is one where maybe it's not saturated. There's not a lot of craters there, and sort of count how many craters per square mile there are, and that gives you something on the age. Here's just a completely independent set of data that can tell you something about the history of it. And we care about this cratering history from 4.5 billion years ago, because the Earth is right next to the moon. So that's the cratering history of the Earth as well.
Yeah.
And most of the
and by
inner
proxy,
solar
most
system.
of the inner solar system, yeah.
And there's still this sort of big questions about how that evolved over the first 500 million to billion years of the solar system.
I really like what they talk about later down in this article, saying that these highly porous deep regions are protected from cosmic rays, which is good for life, and also with more porosity gives you more surface area for water to contact rocks, which also increases rates of chemical reactions, which is also a source of energy for life. And I hadn't even thought about that in terms of linking impact events to improving potential origins of life, and I mean,
I think there's some algae down there.
Yeah, it's interesting.
Yeah. So yeah, I mean, it's always valuable when you have a completely different avenue of attack,
and seeing how they compare.
A problem, and so I think it'll be interesting to see how this sort of investigation and using this kind of data evolves, and we will get more samples with the Artemis missions from a different part of the
absolute
moon
age dating
that we've had before, to tie in some of the stuff in a different kind of, you were mentioning Mare and Highlands, which are sort of the two main different kinds of terrain on the moon. The Mare are these volcanic floodplains.
Yeah, which tend to be sort of these younger, relatively,
Right.
Materials versus the highlands, which is the original moon crust.
The OG.
The OG moon crust.
Yeah.
And then
Wow.
these basins got flooded with this.
And so
And a lot of the area down in the South Polar region, and it's more of the stuff that's on the far side, but it's of interest, is the South Pole Aitken Basin, which is this big, giant basin on the lunar far side that got hit so hard that it probably knocked it like way down and exposed some of the mantle material, possibly, which is further down in.
So, so we will learn a lot. So our other bit of detective work that I'll just mention briefly that I thought was pretty cool also was...
It's not all moon today.
It's not all moon. So now we're going back to the stars.
Jim's not here to regulate us.
Right. And this is about Betelgeuse, a bright star in the constellation Orion, which we've talked about a number of times.
Our old friend.
Because it has known large brightness fluctuations, but it had some deviations from its sort of predictable brightness fluctuations a few years ago, or got very... And you could look at it and see, oh my gosh, the star is dimmer than it was a year ago.
Mm-hmm.
Yeah.
And that was a pretty cool... That's the kind of thing that doesn't happen in astronomy very often.
No.
To look up at the sky and see a star looking
In
different
human timescales.
with your eyeballs, just like that.
One of them's going to go supernova.
It was pretty cool, and it's brightened back up, and we've talked some about the explanations for those particular fluctuations. And Betelgeuse is quite obviously red
Yes.
to the naked eye.
Yeah.
It is a red giant star.
Yeah, it's one of the things about like being able to like look at Orion, right? Either with your naked eye or with a telescope, is that you can look at Betelgeuse and it's red, and you can look at Rigel and it's blue,
Right.
which is confusing
Yeah.
because they start with the
The
opposite,
opposite letters. But there are different kinds of stars in different stages of their lifetimes. And
Yeah.
stars, so Betelgeuse is a red giant, which is a very apt descriptive term, which is not always the
It
case
is.
in astrophysics.
That's
But in this
true.
case, it's right on the money. It is a very big star, and it is very red. And the sun will become a red giant, although not as giant as Betelgeuse, because it's much less massive.
because it's closer. No, I'm just kidding. I'm trying to make a really bad joke.
But that happens when a star exhausts its supply of hydrogen to burn into helium in its core. So that changes the internal pressure dynamics of the star, and it goes through a phase where it expands dramatically.
Yeah, it
And
was burning just helium or
Just hydrogen.
and now it's burning some of the helium.
And it goes through, and it goes through a couple of, it can, depending on how big the star is, it
Yeah.
can go through sort of multiple
Different phases.
oscillations back and forth between main sequence and red giant phase. And there's a map that astronomers use called the Hertzsprung-Russell diagram.
People get mad when I love it. I love the Hertzsprung-Russell
Just,
diagram.
it's just
Yeah.
a throwback to year one physics degree.
Oh, it's, but
It's good for you
it's
to
just a
practice
map
when
of
you
like
take
It is, yeah.
temperature versus color. And
Yeah.
You put stars on it, and there's
They
a
move around
very
sometimes.
prominent line along that, a diagonal line along that graph that the
The
sun
main
is on.
sequence.
It's called the main sequence. And that's where stars are when they're doing their normal fusion stuff
Healthy.
going on.
Healthy stars.
And then in their older age, in their
Mhm.
twilight years,
Mhm.
they move to the red giant branch, which is disconnected from this
Yeah.
other part, and the gap in between is called the Hertzsprung gap.
Oh,
And stars move across that
sounds like a good
very
sponsor.
quickly. So that's why there's not many stars typically there.
That's why there's a gap.
That's right.
'Cause we just don't see stars there.
And on the main sequence phase, a star that would be red when it's a red giant is yellow,
It's more yellow, like our star.
like our yellow sun.
Mm-hmm.
Interestingly, researchers have found that Betelgeuse being a prominent star in historical records, was identified by naked eye astronomers as yellow.
Whoa!
So,
Which means
which means that at that time it was in a different part of the Hertzsprung-Russell diagram than it is now.
Yeah.
so it's
So they-
crossed.
So it has crossed the Hertzsprung gap
Within
within
the
the
history of
last couple of
humans.
thousand years.
Yeah.
And you tie that together with stellar evolution models, you now got this sort of constraint
Better constraint
on things, and you can try to map, okay, it's only been over in the red giant phase for 1,000 or 2,000 years or something like that, and that narrows down the mass of the star, and that then tells you how long it has to go before it does blow. I mean, I told you, Hannah, not to hold your breath, because it looks like it's probably it's probably on the order of 14 million years old, and it is also probably about 14 times the mass of the sun. Ooh. And it probably has 1 million years to go before it blows up.
I like that it says each crossing still far surpasses the longevity of any single astronomer and of most societies.
Yeah.
Of most societies. Oh,
yeah, it's cool
sad.
because somebody's going back and looking through. So they're figuring this out because they're going back and looking through ancient records in China, I think, in this case.
Yes.
And like trying to figure out like what words were they using
Not just
to describe.
China. Not just
okay,
China,
that's
but
true.
yes, but including Chinese astronomers, and yeah.
And like, what words do you use to describe the different colors? Because like right now we have like we use spectra and like specific wavelengths of light to describe colors, but these would have been like word descriptions, and languages changed over time,
and so one of the key
way
things,
you perceive things changes over time.
Yeah, one of the key clues here was that they compared the stars to the planets, and they compared Betelgeuse to Saturn. Looks like Saturn,
yellow.
And Saturn is
Unless
yellow.
Saturn has changed colour.
Saturn, knowing what we know about planets, is unlikely to have changed in that time frame.
Do they compare other things to like Mars?
They do, and they do not compare this one to Mars. And if you were doing it today, you totally would say it is a Mars-colored. And they did say Antares, which is another red giant star.
And that one was Mars-like?
Is Mars-like. And so they have a control there. You know, it's not just this one-off and it's like, that's weird. How come they didn't say this bright star is red when it looks red to us now? There is another star that looks red to us now that they did say looks red. And there's this star that looks red to us now that they say does not look that way.
It's so cool.
I love that.
Because they've got, I'm just trying to figure out who was saying what. That a librarian for Roman Emperor Augustus noted that Betelgeuse was a yellow colour comparable to Saturn, and this was around the onset of the first millennium.
Yeah.
It's just really cool.
So, yeah, very cool detective work, and provide, you know, they did their best effort at sort of quantifying these things, but it's I think it's a pretty compelling thing that something changed about it.
Yeah. It's one of the fun things about astronomy is that it's like so ancient.
Yes, yeah. Well, on the less ancient side of things, we're looking forward to the SLS launch.
We hope we're here for a while.
Which of these rockets, past, present, and future, has the greatest thrust? The Saturn V, the mighty Saturn V, which took the Apollo missions to the moon. The SLS, which will be flying astronauts back to the moon, and will be flying some battery-dead CubeSats to the moon.
Are we ranking these in order, or are we just saying which is the most?
Which is the biggest, the Falcon Heavy, which has flown. The New Glenn, which has not yet flown, but was, I think, maybe less than a year away from its first flight. Or the Soviet N-1 rocket, which was their big rocket to take astronauts to the moon.
I'm just going to go SLS.
I also was going to go SLS.
Yeah.
You can both give the same answer. You don't
we
get
can both have the
out.
same wrong answer.
You can both have the same wrong answer, and you do.
Yeah. Because I don't know anything about the Russian one.
I was surprised to learn, although I think I had known it before and forgotten it. So the SLS is more powerful, greater thrust at liftoff than the Saturn V.
I knew that for sure.
The Saturn V had 7.6 million pounds of thrust. The Falcon Heavy, by the way...
What units of pounds? I'm sorry, I just...
Pounds thrust is like what we use.
What
do European rockets use?
It'd be Newton per square meter.
True.
Well, this would be in newtons total, so this is like... This is, there's 4 newtons in a pound, roughly.
Yeah,
so
it's fine. It's fine. I'll forgive you this time.
It's large numbers anyway. So
Saturn V 7.6
units.
SLS 8.8. Falcon Heavy 5.1.
I thought Falcon Heavy was less.
New Glenn only 3.8.
Yeah, because it's just an orbital.
That's
we would
right.
want to do New Armstrong to compare
Right.
apples
Well,
to
but
apples.
that's not really
It doesn't all,
defined
yeah,
yet.
yeah, I know.
The N1 10.2.
Wow, I should have guessed the
And
Russian one.
I had not also appreciated or remembered it did launch 4 times.
Okay.
All of those launches ended in relatively early explosions or
Yeah.
shutoffs
Too
and
much
crashes
thrust.
back. No,
No.
they hadn't really done the ground testing. The Saturn V had 5 ginormous, powerful engines.
Yeah.
The N1, sort of similar
What
to
were
the
the engines?
SpaceX Super Heavy, had a gajillion engines, and that makes things much more complicated.
Yeah.
And that had not been thoroughly tested.
That
and
scares
modeled,
the poop out of me for the Starship and stuff.
which is your follow-up trivia.
Oh god.
What in these same units is the thrust of the SpaceX Super Heavy,
That's it.
which we do anticipate a launch now, perhaps within the next 6 months, the first orbital launch.
In those same units. Super heavy.
SLS
I know
being
nothing.
8.8,
What was
Saturn V
heavy?
7.6, Falcon Heavy 5.1.
15.
12.
16.
Yeah,
Whoa.
it's like 3 times the Falcon
Jeez.
Heavy.
Yeah.
It's got something like 27.
Up to 33
Yeah.
Raptor engines
Oh my
in
God.
the main
Scares the-
stage.
What are the
It's like-
G-forces
it's-
going to be?
Well, not so
Not
much,
so
because the
much.
thing is, it weighs so much.
Yeah.
The
It's still-
maximum accelerations or G's that are experienced on these flights is not at liftoff. It's not even with the first stage. It's
Yeah.
after you dump that first stage and all that mass.
It's gone.
So then
And then
you've
you go-
got the huge acceleration available.
Is it so it's got all this thrust so it can carry more?
Yeah.
Yes.
Yeah.
Yes. So a greater payload capacity to Earth orbit, but also a greater payload capacity to the Moon or interplanetary as well. But the sort of crazy thing about rockets, right, is that always roughly 90% of the mass is fuel.
Yeah. There is a
And
a
so
limit.
you lumber off, you have this huge amount of thrust at the beginning, but that's because you've got all this damn fuel you've got to lift up. And all of that's just to get you going.
And that's
you
where
know?
the
Yeah.
Moon petrol station comes in.
That's
And
right.
gas
Or
station.
or in between. Or
Yeah.
Like a halo orbit, for instance.
And that's when you you dump that lower stage.
Yeah.
Then you don't have as many engines, but you have so much less mass
Yeah.
that your acceleration gets really, really large. Well, while it may have felt like waiting for Betelgeuse to explode, it was just another episode of Walkabout the Galaxy. Give us 5 stars and we'll give you the universe. Be sure to follow us on Facebook and Instagram to get all our updates, and check out our website at walkaboutthegalaxy.com. Subscribe to our YouTube channel where you can see most of our episodes, some of our bloopers, and now silly shorts.
Hit that subscribe button
Catch up on old episodes wherever you get your podcasts. Follow us on Twitter
at walk_the_galaxy.
and ask us questions anywhere using hashtag AskWTG. Our theme music was composed by Richard Tarusik. Production assistance is provided by Logan Basinger. Thanks to our listeners in Southwest Australia and around the world. Stay safe. I'm Josh Caldwell.
I'm Addie Dove.
And I'm Hannah Sargent.
We're the Astrocork signing off until the next episode of Walkabout the Galaxy.
Beetlejuice.
News alert.
Why don't you?